Welcome to Nerd Vision. In our channel, we upload many interesting facts, both entertainment, comedy, and lots of fun. To get more content, please subscribe to our channel. Today we will be talking about one of the most famous formula of the history of physics, which is quite common. Everybody has seen this formula: E equals to mc squared. But what actually is this formula? Everyone talks about it, everyone knows about it, everyone has seen it. But what does this mean? It has been made by a famous scientist, Sir Albert Einstein, in his one of the most controversial year of 1905 in his 5 journal paper. Now, today we will be taking a look of how this formula has been derived. We will be trying to do it in a much more simpler way such that a student of standard 8 can also understand. Now let's start with the derivation. Before starting the derivation, we need to know a few things. First, Doppler effect. Second, the momentum of photon. Third, the idea of frame of reference. Now, these are the 3 basic things you need to understand, and some really simple algebra which we have been taught in standard 6 and 5. Now let's start with the proof. Suppose this is a train and you are inside the train. Let's name this frame of reference in which you are as S prime. Now there is a box, a mystery box inside this train, and the train is moving with a constant velocity of u. Let's say this direction is x. We are in this video we will take only one dimension, but for a more general proof you can take a lot of more dimensions. The mass of this body is m. When I am inside, we know every body, every matter emits photons. When I am inside this train, I will see photons emitting from this body. Let's say these photons that has been emitting in the direction x are mu naught. So the energy, the change in energy before the photons were emitted, after the photons are emitted, that can be written in my frame of reference as 2h mu naught. Now this is a very interesting analogy that mass is releasing some photon, and can this thing be in relation with mass? Let us see in the future of this video. Now we will calculate the momentum change of the photon in the frame, in my frame of reference, which is in our x direction. We can say it is mu naught, and in our negative frame of reference we see that minus mu naught by c, which is 0. So I am happy. I can see that the change in energy is 2h mu naught, but the change in momentum is 0, and I am quite happy because nothing anomalous has been happening in this formula. So let's think about the person who is standing outside the train. Now I am standing outside the train. I was happy, but the problem arises. I saw two different frequencies of light emitting this time due to a very famous formula known as the Doppler effect. Due to Doppler effect, I will see the energy. I will see the energy of two photons to be slightly different this time. We can find the formula for the Doppler effect using. This is a very formula. This is a very famous formula, and we call it as Doppler effect. Oops. Uh, I made a spelling mistake. Sorry.
Bazinga!
Sorry. There won't be any art. In this video, we can see the Doppler effect is causing a main problem here. What is the problem? Let's see. Now let's see the energy. Now the frame of reference in which I am standing, let's call this as S. Now the change in energy in my frame of reference is 2 h mu1 plus h mu2. Now let's find out what is after doing some algebra. Now on further simplification, we can write. Now this is a very interesting formula that we have found out. Now this time we have found out that the in energy change in energy is dependent on the velocity of the train. Now this is something very interesting and unexpected. Now, as we have seen before in this formula which is given before, we can see the relation between the energy that this person 1 has seen and this person 2 have seen. Now, we can write this as now. Let's come to the momentum part. We have calculated the energy, the momentum for the S prime frame of reference. Now we will calculate the change in momentum and the energy for S prime S reference. Now we will substitute again the Doppler effect formulas, and after doing the same type of simplification as it has been done here, we will get something like this. Now, on further some simple algebraic simplifications, we can rewrite this formula as now. Something very interesting has occurred. We can see the change of momentum is no more the change of momentum is no more zero for my frame of reference. But we normally have seen that the change in momentum is normally due to the change in velocity. But in this case, there is no change in velocity. The velocity is remaining constant. So we can say the mass of the body is changing. From there, we get the idea that speed can cause some change in velocity, some change in mass. Let's consider the change in mass in my frame of reference as delta ms. And as I am moving in velocity u, so still u. Sorry, I made a glitch. As I was calculating for momentum, we should divide by c, and similarly we should divide by c here, and we will get x to c term here. Now this is something very interesting that has come out. C square minus u square. Now u gets cancelled from both sides. So we can write delta m in S frame of reference as 1 by c 2h naught by c square minus u square. On further multiplication of c up and down, we will get something like this. On further simplification, we will get 2h mu naught divided by 1 by u square by c square. Now this part seems to be familiar. We have seen this somewhere before. Where? Wow, we have got this here. Now we will use this as a formula. Now let's simplify. Now we got something very interesting. It shows that the energy change in my frame of reference is equal to the mass change that I will see in my frame of reference. From here, we will get a very direct relation that the change in mass is directly related to the change in energy. So in simple words, energy is nothing but mass. That is the basic idea for E equals to mc square. Now many guys have seen this formula as E equals to mc square, but we will talk about it in the next video. Thank you for, and if you like this proof, please like our channel, and please like our video, subscribe to our channel, and we will be coming up with more such videos. Thank you.